Now examples 3 and 4 deal with some situations that happen enough that we need to deal with it, and it's more along the lines of this is what I want your answer to end up looking like, as opposed to it's any different than the last problem. Okay? Same basic structure going on here. We have a binomial expression squared equals a number, and again, all I'm going to do is I'm going to say this thing here is p, which is being squared. The difference of two squares theorem tells me that that object not squared should equal the plus or minus square root of 16. Okay? The difference here is everybody knows the square root of 16 to 15,000 decimal places is 4. Point a bunch of zeros, right? So it's 4. So watch what happens. So I'm going to move the 5 over like I did the last time. So I'm going to get x equals what kind of 5?
A positive.
A positive 5. Plus or minus. But the square root of 16 I'm going to change to 4 because that's what it equals. Now the last thing I want you to do, the last problem I had a negative 2/5 plus the square root of 3, negative 2/5 minus the square root of 3. There's no way to add a whole number of a fraction to a square root if the square roots don't match, right? But here I've got a whole number plus or minus a whole number, okay? That means 5 plus 4 is 9 and 5 minus 4 is 1. I'm looking for actual numerical answers when you can actually do that. Do make sure that if you get a nice pretty number like 16 that has a nice pretty square root like 4, that you actually add the two numbers and subtract the two numbers to get the two actual answers to the problem. Okay, that's what I'm looking for. Now, real quick about this problem. If I just took this expression and got it back to simplified form, x squared minus 10x plus 25 is equal to 16. Squaring a binomial, square the first object, you double the product of the two, you square the second object. And if I move the 16 over here, that gets me x squared minus 10x plus 9 is equal to 0, right? Move the 16 becomes negative and subtract. And that factors to x minus 1 times x minus 9 equals 0. And that factor gets me x is equal to positive 1. That one gets me x is equal to positive 9. See, the answers are the same? All right. Again, the technique we're going to learn completing the square is to solve problems of this variety. This is the place you'll get to in those problems. Obviously, if it looks like this, I want you to go through this technique because I want you to master this technique. Just know that what these are represent the solutions to a quadratic equation. Alright, this is just a different form of a quadratic equation we're going to be creating down the road. So, and 9, 1, 1, 9, the reason that order doesn't matter there, it's not an ordered pair. The answers to this question are 1 and 9. Take your pick on whatever order you want to put them in. But again, if you get a nice pretty square root, I'm expecting answers looking like that. If you give me this or this, like, so 5 plus or minus the square root of 16 or 5 plus or minus 4, you're being a little lazy on me. I'm not going to give you full credit. So get me all the way down to nice whole number or integer answers when you are capable of doing that.